Welcome back, ladies and gentlemen. Today we're going to talk about writing numbers in standard form from scientific notation. So let's get right to it. So standard form we want to define as just what we're used to seeing, I guess, is the best way to think of it. So standard form of a number is just going to be decimals, fractions, and percents, if we want to look at it, because every number that we've ever seen since we learned how to count has been one of these three. Now, decimals and fractions are what we're going to be used to, but if you notice, scientific notation always includes a decimal. So really what we're going to be concentrating on is, though these numbers exist and we can move between them, they will be an afterthought. They'll be after we do the following. So what we're talking about now is really, how do I take a scientific notation and turn it into a standard form of a decimal that I'm used to seeing? All right, so the first step is to look at the exponent of our power of 10. If it's negative, it means we're moving left, and if it's positive, it means we're moving right. What that means is, if I have 3.22 times 10 to the negative 4, it's the same thing or equal to 1, 2, 3, 4 movements to the left. So I'm going to rewrite this as 3, 2, 2, and 4 movements to the left. Well, here I need to keep track and say 1, 2, 3 zeros. These are what we call leading zeros. So those are going to be put in 1, 2, 3, and that's where my decimal goes, and then I always want a 0 here. So 3.22 times 10 to the negative 4th is the same thing as 0.000322. That's it. That's all we are doing. 0.000322 is our answer. I did that just because there's not much room here by the equal sign, and I didn't want to overlap something because my organizational mind is kicking in because I'm getting tired. So there's no other reason to rewrite it other than my brain said there wasn't enough space there, so I rewrote it to box it in. All right, so if we move left when it's negative, think about it like a number line. If it's negative, we move left. We move when positive. So which way would we move when it's positive? We're going to move right. So that means I'm going to take 7.9 and I'm going to move 1, 2, 3, 4, 5 times. So this was from here. I'm trying to think of the best way to notate this. So 5, which was this 5 right here. So that's how many times we move. And then every time there's a blank spot, I'm going to fill it with a 0. So that's the same thing as saying, actually times 10. Well, let's write it like this. Here's the times 10 to the 5th, and 7.9 was our original factor. So it's the same thing as 7, 9, because remember, we've moved the decimal. I don't want to put it here. 0, 0, 0, 0. Now, in our system, every time there's 3 zeros, we like commas. Sometimes we don't. I do. It's a nice separator. If you don't enter it, oh well. Pardon me. However, this is our final answer. So all of these zeros in red just got moved in. The decimal's here, but we don't put trailing decimals. We just leave it blank. That'd be the same thing as writing 10.0. We don't do that. We just write 10. So this is 790,000. We moved right because the exponent was 0. So here, this is what the 10 to the negative 4th was. These are the movements. The movements are the times 10 to the negative 4, which was this part right there. And this whole part right there is what moved the decimal to the right because it's positive. Now pause the video and copy what is on your screen into your notebook. Now that you're back, anytime you have to rewatch the video for clarity or to remember something, you need to write what you picked up into your notes. Use arrows, circles, shapes, pictures, whatever else you need to, but add it to your notes to make them yours. Last, ladies and gentlemen, you are in school. When we're learning, it's about understanding the process, not about finding an answer. We'll see you tomorrow.